будет смотреться.
Так.
Тут все очень просто. Зеленый квадратик. Да. Да.
Все, появилось слайд.
Ну, у тебя видно.
Не надо. 2 человека уже
Какая
смотрят.
задержка?
5 секунд.
О, пошло.
Зеленый?
Да, уже запустилось.
Зеленый квадратик хорошо, красный квадратик все плохо.
Спасибо. Давай.
Да.
Короче, все полностью известны.
Я думаю, через часик будет точно.
Они должны просто замокаться и ничего не вернуться, а другие полы, которые они все отвечают на, собственно, они ничего не вызывают. Ну, собственно, каждый смысл юзер делает.
So, hello guys, hope you are hear me well. So, what we are going to talk today about, we are going to talk today about Docker. I hope you can hear me well. So, if I have any problems with microphone or if I have any problems with my presentation or screen sharing mode, please let me know. We have 2 chats, one chat in YouTube directly and the second chat is our sales squad, is our Slack channel. So right now I already see that someone wrote that you guys can hear me well. So let's start. So for those people who does not know me, few words about myself. My name is Alexander Velichko. Currently I'm working as a Java developer on Sales Quad version 2 project. So also a couple of words about me. I have 10 plus years of experience in Java technology stack. So mostly is Java with web frameworks and cloud solution. So today we're going to take a brief look at the Docker side. So what we will see there, let me turn the present mode. Jack Rice, I see that you asked me about the conference call. Since like 80% told me that they want to join, we will not have a conference call today because of Nextiva. I'm not sure that Nextiva app can handle it, but I hope it can, but I don't want to take additional risks. So right now we are starting our Docker meetup. So we are not going to take a deep look into the Docker. I often hear from people some weird explanation of what is Docker, how to use it, and I see that many people in Kiev, I don't say Kiev office, just in Kiev, are not really familiar with Docker. So today we're gonna to look at the Docker and try to answer on several questions, such as who is Docker, what is Docker, where is Docker, how does Docker works with Java, how does it look, some Docker commands, maybe if we will have sometimes we will speak about Docker Compose, then I will try to answer some Docker question. And in additional way, I will take just a few words, but I will speak just a few sentences about Docker cluster management, because this is a big topic that probably needs another presentation. Also, after this meeting, you will all be able to see this video on my YouTube channel. So if you want in future to see some other additional videos which we are going to deliver for the Nextiva, you can subscribe for it. I believe we will have a lot of videos about Nginx, Linux configuration, Spring Cloud, Amazon Web Services, Spring State Machine, and so on. A lot of things we are really plan to speak about. So let's start first off. And as you see at the bottom, we have Slack channel Docker Meetup with a typer in the name. So if you want to ask any question, please type into Slack or directly in live chat. So this is it. So the first question what we are going to speak about today is who is Docker. I know that this is not really valid for the English people, but for me what I want to describe here is that a lot of people are using Docker. You can see on the next slide people like big companies and small companies such as Baidu, Yandex, eBay, Yelp, Atlassian, and many other people are oftenly using Docker, and even Google use it in some cases. So this is not something unique and not something like say from the hipster world. It is something that is widespread in the IT world today. So the next question what I really want to speak about today is what is Docker, because it's probably the main question. First of all, we need to think about the Docker, that it is like one part of the Docker, that the Docker is some kind of alternative to the virtual machine. So as you know, in usually in the DevOps world we need to set up several virtual machines. On each virtual machine we need to configure everything, and then somebody can work with our application. This is not a bad approach, but as you may see on this slide, this approach has some problems, which I think that it is a problem. For some companies it's not a problem. First of all, when you set up virtual machines, it is something that take a lot of resources. And the second part, you can always break something on your file system, on your local machine, and you can always lose some sensitive data when you work, like say, if you have a virtual machine on Windows, for example. As an alternative for that, we can speak about the Docker. So Docker is about the containers. Mainly we have single kernel, and on each kernel we can, launch several containers. Each container can be a dedicated like alternative to virtual machine. So let's take a look further. On this slide we can see the main difference between the virtual machine and container. So as you can see, we have several applications. Each application contains its own business libs, some kind of additional required dependencies installed in that. And on the right side we can see that for each application we need our guest operation system, which requires a lot of resources. On the left side we can see the realization on the Docker side. So we just need to launch our application on our container, and all applications will be run under the Docker. So that's it. What we need to think about, that basically Docker is a kernel, and on the kernel we can put as many containers as we want. Each container can contains whole our application and dependency, like a monolith container. It is useful for, let's say, on my previous job we had experience when we was working with the team who were great experts in the front end, but they were completely not aware about Java, and all our infrastructure were packed in Docker container and delivered to them. And same things were relevant from their side. So they just give us a Docker container with all their required configuration, and all these configurations were up and running on our local machines. And we were not aware about Nginx, we were not aware about Node.js application. Everything was under the hood in Docker. So the next thing, the next way how we can look into the Docker, that first of all, at the bottom we have a kernel which contains our bootfs. Then we have our images, and all images runs under the container. So image is something new to us. So on the next slide I will try to explain the workflow, live workflow of the Docker images and containers. So I was too lazy to write good pictures here, so that's why I have just take this picture from my shell. So as you can see on the first picture, Docker files build Docker image, which also can be downloaded from Docker repository. We will speak about the Docker repository about few slides later. Then the second part, user starts container after image was downloaded. So on this part, when we download image from our repository, we say, hey, just launch me the container, and the container runs. So basically the container is an alternative to the virtual machine, let's say like that. And when the container is up and run, we can execute some commands inside this container. For example, hey, give me all logs, or show me all the processes which are running currently. So this is a simple workflow. So the next question which we are going to speak about today is, where is Docker? So in this topic we are going to speak about the Docker repo, the Docker store, and the Docker file itself. So let's try to look at the next slide. So on this slide I've made a picture of my private repository, which is empty now. Let us try to see it. Here on the upside of my screen we can see the Docker icon. Here we have some menu elements. We can see the Docker store, we can see the documentation, we can see my repository. So let's take a look at the phone number repository. Oh, I need to log in. Hope that everything will go fine. So now I've logged into this repository. As you might see, it looks really looks really close to the Git repository, because first of all you can see that you can push something into the Git repository, you can see the builds which were run. So you can add LinkHub, Bitbucket here to see the builds. All your builds can be marked as tags. I was trying to put something into this repository, but I was a little bit afraid about the NDA, so that's why this repository is empty. I don't really know, can I put Nextiva services in the public repo, even in private mode. So this time you'll just see blank repository. So what else can I show here? Here is a Docker store and documentation. First of all, Docker is a very well documented feature, so when you install Docker you are always have an easy access to the documentation and to the configuration, which is pretty good. So let's get back to our presentation mode. Present. So the next thing is Docker store. So for most of our needs already exist Docker store. Already exists a Docker image in the store. Most of these images are free to use. So let's say I need to find a Docker image in this store. Let's say Redis, for example. Let's go to the Docker store. Let's type Redis. So as we can see, here is the official image, official Redis image to the Docker. So let's open it. As you may see that this Docker image is well documented. So a lot of reference, a lot of documentation, clean instruction how to up and run this service. So this is very pleasure to work with it, because you don't have to think hard how to launch, how to install. All you need is to run docker pull Redis in your command line, and then when it will be downloaded you need to use docker run with the following parameters, and then your Redis will be up and running. Here is some extended enhanced parameters which can be used for Docker run, but we will speak about these parameters a little bit later. So let's get back to the presenter mode. So the other thing about where is Docker, we can find Docker in, we need to speak about Docker file. So here is, I proposed just Docker syntax, as you can see. So what we are going to do here, the first line tells us that we need to download the official image Python 2.7. Then we need to set up work dir called app. Then we need to add this dir, and then we need to run the process install inside this file. Also, we need to make some DevOps configuration, for example, expose port 80 to the local environment. I will tell about it a little bit further, and set up some environment variables and execute some command line tools, as you might see at the bottom. So this is just example. We're not going to work directly with this example. This is just a syntax example. So Docker is about like Docker DSL has something like 20 or 30 operators. So it is not complicated to learn it. It is just a matter of 1 day or 2 days to read the documentation. So for the documentation, I've also added a couple links here, which I hope will be useful for you. The most useful link is the second. It tells how to. It tells us about the best practice to write Docker files. So I hope if one day, if someone of you will try to create Docker image, this guy will look into this link. Two other links are related to the Docker syntax, how to use it. But as you see on previous example, it is not something really complicated. So the next slide is probably more related to the Java developers. So for the guys who are using Python, you can guys, do you see my screen? Just a second. Looks like we have some kind of technical problems for a moment. I hope everything will be restored right now. So please take a look. Just let's wait a couple more seconds. Okay, so once again we back to we get back on the rails. So let's get back to the Docker and Java and Maven. How does it looks and how does it works? I often hear that it is very complicated to integrate Spring Boot with Docker because DevOps departments are usually not familiar with Java world, and Java world usually are not familiar with DevOps world and how to tie everything together. Well, this is also not a complicated thing, so let's look into the next slide. First of all, we need just to add one single plugin to our dev project. So what does this plugin called Docker File Maven plugin? So what does it works? So how does it works? First of all, it's processed the repository file, the path to your repository, and then it builds your local Docker file using the project build result. So I will show how does it work in the next couple minutes, I believe. And the second, what we need to do, we need to write our own Docker file. As you see, this file, we're going to use this file on this example. So we are going to launch some kind of Java microservice on Docker. We are going to use OpenGDK version 8. We're going to build our jar file and upload it to the Docker file and to the Docker image inside it. And also we are going to set up some additional configuration for our jar application. We have here one single property called Java Security Edge. So why do we need this file? This property is used to turn on the special library which are properly generate random digits. So without this property, our sessions on Tomcat or any other app server won't be unique. But for the development process, for the development purpose, we don't need to specify this property. So you can write the article below. So as I just copy paste from this article, the library used for random number generation in Oracle JVM relies on def random by default for Unix. Here is the next slide is Maven lifecycle. So as we can see, first of all, what we are executing is Maven package. Then we can build Docker file, and then we can push Docker file to our repo. So let's get to the practice. So here on the following on the screen you might see my IntelliJ. We have a very simple application with just one single class, Spring Boot main class, and with one single request mapping. In this request mapping it says when we will launch our application and we will try to visit its home directory, we will see hello Docker world. So it is not something complicated. We have our Docker file which I have just demonstrated to you. I would also like to show you my POM file. So in POM file, as you can see, we have just a Spring Boot starter dependency, and we have configured our Spring Boot Maven plugin, included, and Docker Maven plugin included, as I just showed you previously on the presentation. So, oh, sorry. Let me try to run to build our application. So right now I switch it to it. Let's try to build. So mvnnt is an alias for Maven clean install. First of all, let's check that everything is okay. Yes, everything is okay. Then let's try to build our image. History grab Docker. I heard some questions, so could you please repeat your question? Oh, just a second. I will try. So, do you see my screen well now? No? Okay, I will zoom it a little bit more. So, I just forgot the comment I don't want to retype it. So, Let's try to execute follow-on command. So we're going to make clean install for our project and then build our Docker image. So, what I want to show you, first of all, it includes some kind of tests which checks if Docker is alive. And second, in the log you will see the execution, how does Apache plugin, Docker plugin builds our Docker image. So here it is. As you can see, it shows us that our Docker file contains 5 steps. First step, we are downloading OpenJDK version 1. Second step, we are mounting our volume. So I didn't add anything about volume inside this video, but I will tell about it right now. So basically, Docker is something that is completely isolated from the system which launch Docker. Docker image is isolated. So if you want some folders to be shared between Docker and your current operation system, you need to use volume. You need to mark one of your directives as volume for the Docker, and then this directory will be visible for the Docker as itself. The third step, puts argument as a jar file to the Docker. The fourth step, copy the result of Maven clean install to the Docker. And the fifth step is to set up main Java entry point. So this command will be executed when we will try to launch our application. So now our Docker image was Docker file built in our image, and right now we will try to up and run our controller. We will try to up and run our container. Just a second. History. Grep. So here we're going to execute following line of code. We are going to run our image using the docker run command. -p option shows that port 8080 will be mounted to the local port 8080, and we are going to use Docker image with name Spring.io Spring Boot Docker. So to see the list of Docker images to get this name, we will use the command called Docker image images. Yes. The result of executing this command shows all amount of Docker images which we have right now installed on my local PC. As you see, we have 3 Docker images. One is Spring Boot application, the second is my internal project phone number service, and the third, my another internal project, is signature var file. So this is also an Nextiva service. So let's try to run. Let's try to run this command, and -t options show us the log. So as you can see, our application is up and running now, and we can try to look it into the browser. Let's get back to the browser and see localhost 8080. So as you can see, our application shows Docker hello world, so that's a good result. So as you may see, Docker is not something complicated to work with. Let's go next for our for our presentation. Presentation mode. So right now we are going to speak a little bit about the main Docker commands. Most of these commands are pretty same as Linux commands. We can divide them into the 6 groups. Common Docker commands for the kernel. We can see Docker versions, some info about the Docker updates at the top level. The next is Docker image commands. So we can see see the list of existing images. We can see the list of images tags and so on. And we have several commands for the Docker container, such as start, stop, restart, exec, top. On the upcoming slide, I will show you the list of most useful commands and oftenly used by me commands. So this is like 8 or 9 commands. Let's try to run them all. You already see Docker run command, the second one, so I will not go into show it once again. I also show you Docker images with option --all. So we will try to see all images, which Docker images -all. So the result is basically the same. Zoom. Yeah. So what does it show? It shows a little bit different way of representing our images. So it shows us the repository names which we use it for the images. It shows us the tag for the images, image ID, size, and status when it was created. Let's get to the next command. The next 2 commands would be Docker PS and Docker PS --all. So let's try to execute it. Basically, it is the same thing as Linux PS. So let's try to execute Docker PS. It is not very useful right now, so I will make a smaller. It shows the container ID. It's still not really good to show. Sorry, guys. The result of Docker PS shows the container ID name, the image name, the command which was executed or executed in the present period, when it was created, when the status of it, some configuration, like let's say the port configuration or volume configuration, and randomly generated name. Here we have X and I will not try to read it. So we can use this name as an alias to get access to this image. So if I will try to execute same command with --all, then I will see the list of all applications, all images which were up and running during some period of time, how they were closed or how they were created or terminated. So for example, 3 weeks ago I created one image and it was terminated with an error 143. As far as I remember, it is something like main file not found. So let's get back to the list of commands. The next one is Docker logs. So First of all, we need to get Docker images. Image ID, and now we will try to get Docker logs from the image which is up and running now. Docker logs. I don't remember is it needs to be an image ID or container ID. So, just a second. We need to specify. We need to specify container ID instead of image ID. So, Docker logs. And as you may see, it just types us the whole log file. If you want to use such tools as tail or some other Linux command, you need to execute docker exec command. So let's say docker exec. We will see the ls. So I executed ls command inside the Docker. Let's get back to our slide. Docker top shows us a memory. As you may see, it works directly the same as I showed on previous. Docker history shows the history of what was run, and the Docker stop the container. So I will not try to show this command right now because I believe we have some time limitations. The next thing which I want to talk about is Docker Compose. So often, let's say you have 10 or 12 or even more Docker services, and you need to launch all these Docker services. It is hard to type every time Docker run dash and etc. So you can put all these Docker run commands into the single YAML file, which called Docker Compose YAML, and then you can launch Docker Compose YAML utility to see how does to start all the services. So YAML descriptions is going to be processed by Docker command line, and then Docker command line will going to use it in Swarm and deploy it via the cluster managers. So how does the Docker Compose YAML looks like? Here we get a Docker Compose sample. So what we have here, first of all, every Docker Compose YAML needs to have its version. It needs to be specified. So the version is equals to 3. Then we have two services there, one called web service and the second called Redis. So the web service going to be, first of all, it will be built from the existing directory. Second, port number 5000 will be exposed to the Docker, and this service is going to send the request to the Redis service. And the Redis service image will be downloaded and run with default parameters from the official Redis hub, Redis repository. So here is a link, Docker Compose Get Started. You can learn there how to properly write these YAML files, best practices, but it is also not something that is not really complicated. On this slide, I just here is written basically the same which I just told, so we will not stay here for long. And the final topic which I'm going to speak about today, we are not going to speak deeply about the configuration, we are not going to speak about the benefits of using of it, is clustering, Docker clustering and container orchestration. So for many companies, Docker Compose is not something that is really suitable, because this company has a lot of services, and these services needs to be quickly deployed, quickly redeployed, run it under the cluster management, and they need to they need a tool which can deliver some kind of container orchestration and deployment for the clustering. I know two main applications which are work with Dockers. One of these is Mesos, and the second one is Kubernetes. So few words about the Kubernetes. It was developed by Google, and then it was in March 2016 it was given as a present for CNCF company, and these guys are still continue to deliver it, still continue to maintain it and deliver a lot of new features there. So basically, to work with it, we need to set up Kubernetes master, and we need to set up Kubernetes nodes. In each node we can have as many Docker components as we like, and all these components will be managed by Kubernetes master. So this is some information which I copy pasted from the Wikipedia about how it was built, who is responsible for it, why does developers like Kubernetes. So I don't think that we need to spend much time on it. If someone like them, they can look in Wikipedia about it. The next thing is Apache Mesos. Apache Mesos was built by US Berkeley. These guys were trying to deliver some kind of alternative to Google Borg and analog of Google Borg from the Facebook. This solution was pretty good. A lot of companies such as Yelp, Netflix, Confluence, Twitter are still trying to maintain it, try to make it better. They really like it. So basically it's work, the way how does it work is something not really different from the Kubernetes. So you also have your Mesos master, and this master managed the special nodes. This node's called the agent. On each agent you can have your Docker components. That's basically it. So guys, if you have any questions, please feel free to write them and ask. I will try to answer them, most of them. Once again, I will not be able probably right now answer on the question about Kubernetes and Mesos, because I know that Maxim Vasilets is responsible for Kubernetes, and he knows better about the performance analysis of benefits using Kubernetes, and difference between Mesos a little bit deeper than I do. So that's all. After this video will end, I will send to the Docker Meetup channel and into the general channel this presentation. So if someone would like, then you can always take a look at this presentation and maybe see something useful for you. So that's all. Thank you for watching, and have a nice day.